Well, hello, how are you today? Today we're going to talk about Lesson 69, and Lesson 69 is about the proper form of scientific notation. Now, before you think too hard on that one, I didn't realize there was an improper form, right? Okay, well there is an improper form, and so we want to talk about what scientific notation really should look like. Usually, when you see scientific notation, you're going to see something that looks like this. 4.6 times 10 to the third power. You never have more than one number to the left of the decimal, and it's always times some power of 10. Now, it could be a positive power of 10 or a negative power of 10, but generally you're going to see it look just like this. The standard form of this same number is actually just writing it out like you would normally see it on a regular day. So you got scientific notation, standard form. Really important to get that in your notes, because you're going to have questions on your tests and your quizzes that say, write this number in scientific notation. And it has to be one number to the left of the decimal times 10 to some power. If they say, take this number that's in scientific notation and write it in standard form, then you know you're going to be moving that decimal place however many spaces it says. If it's positive, you're going to move it to the right. If it would be negative, you would move it to the left, and you would write it in its standard form. Sometimes they give us expressions that are pseudo-scientific notation. In other words, they look kind of like scientific notation, but they really aren't scientific notation. And so then we have to figure out how we can change those from the pseudo form to an actual scientific notation. For instance, here's an example. Okay? Now, what is wrong with this pseudo-scientific notation? Well, if you said the decimal place is in the wrong place, you would be absolutely right. That decimal place really should be right here, not here. Because remember, up here we said can only have one to the left of the decimal. Well, it appears down here that we don't have just one to the left of the decimal. So the first thing we have to do is figure out how we're going to do that. So let's look at a couple other examples. All of these are pseudo-scientific notation. In other words, they really aren't scientific notation because they're not written correctly. Okay? So we're going to try to fix some of those so that they actually are in scientific notation so that you know what to do with them. These are all wrong. These are not, these are improper forms. So if you write these in your note, which I hope you will, just to kind of remind you of what it shouldn't look like, these are all improper forms of scientific notation. So how are we going to fix that? Okay, well, what is the difference here? We have one number to the left of the decimal. Turn the slide on so it's just a little bit brighter. There we go. That might help a little. Okay, we have one number to the left of the decimal here, but we have no significant numbers to the left of the decimal. Now, I said significant numbers. Okay, a significant number is a number that really shows place value. Okay, this doesn't necessarily, we don't need that 0 there, but we do need a 3. Okay, we have to have a number that's going to show place value. So let's see what we can do with this. This is okay, this is not. Guess I made that very clear underneath, huh? Alright, so in your notes note the decimal places, mark this one as correct, scientific notation, and not scientific notation. So you have it in your notes. So the big question of the day is, how do we change from improper scientific notation to the correct form? We're going to start with this particular example, okay? We have 3,900 times 10 to the second power. Well, that is obviously not correct scientific notation. There isn't even a decimal in this number at all. So we know we have a problem right away. Where would that decimal go? If you said between a 3 and a 9, you would be right. But then if we do that, we'll have to change this. Otherwise, we would have the wrong number, the wrong standard form in the end. So we're going to work on seeing if we can change this 3,900 times 10 to the second power into a number that is the correct scientific notation. So we have to deal with one thing at a time. We don't want to get too caught up in too much or we will forget what we're doing. So let's look at the 3,900. Okay? We are going to just deal with this first. Okay? And we're going to rewrite this 3,900 itself into correct scientific notation. We kind of know how to do that, okay? So let's do that. So we took 3,900 and we rewrote it as 3.9 times 10 to the third power. Now, just to check ourselves, I'm going to go down here. All right, 3.9, and then I'm going to move it. 1, 2, 3. Yes, that is correct. So this is the form for 3,900. We did this part first. We got it in correct scientific notation. Now, we have to bring the 10 to the second power down too. We can't forget that. So this is how we're going to write it, and it seems kind of confusing at first, but it will keep you from making mistakes in the long run. 3.9 times 10 to the third power times 10 to the second. Because we can't forget this 10 to the second. We ignore it to start with, but we can't forget it because it's still part of the number. Okay? So we know that if we take a power of 10 times the power of 10, we just add the exponents. So now it's 3.9 times 10 to the 3 plus 2 power, which is 3.9 times 10 to the fifth. And now we have it in proper scientific notation form. And in standard notation, we would start with 3.9, okay, and we would just simply 3.9 times 10 to the fifth power. So 1, 2, 3, 4, 5. Put in your new decimal place. And now our new number is 390,000. So that's standard notation. That's what it looks like in standard notation. Now it's important that you know how to do that. Okay, here's a practice problem. Write in true scientific notation and then in standard notation. So you've got 160 times, let me get a piece of paper here because I'd like to use that. Sorry. 160 times 10 to the second power. Okay? Well, again, we have to concentrate on the 160 first. So we would write this as 1.6 times 10 to the, well, we go 1, 2, 2 power. And then we bring this one down times 10 to the 2 power. And ends up to be 1.6 times 10 to the 2 plus 2, which is 1.6 times 10 to the fourth. It is now in proper scientific notation. And then we write it in standard notation so that it is correct now. It's 1, and you go ahead and write your 6. Here's your decimal place. 1, 2, 3, 4. So now we have the true scientific notation, and we have the true standard notation. Okay? So that's important that you know how to do that. That's one of those things that you have to know how to do. And of course I have it rewritten here so you can look at it again. Alrighty. Now, we're going to do just a couple more practice ones just to make sure that you're on with us and know what we're doing here. Okay, we're going to take this number, which is really a little bit of a different look at it. Okay, we have 0.017 times 10 to the third power. Okay, so remember the first thing we have to do is we have to deal with this one first. So this is 0.017. We are going to change that into scientific notation. So we want the decimal to be here. So we're going to write it as 1.7 times 1, 2, 10 to the negative 2 power, right? Because once you get it here, you have to take it to the left to get back to its original, times 10 to the third power. 1.7 times 10 to the negative 2 plus 3. You're still adding them, but you got a negative there, so that's going to make a difference. 1.7 times 10 to the negative 2 plus 3 just leaves us as 10 to the first. Okay? And then we would take 1 and then put our decimal right here. This is scientific notation. This is the true. And then we have 1.7 times 10 to the first. Here's your original decimal place. You're going to move it 1 to the right. And so its true standard notation is just 17. You should just take it 1 to the right because you're multiplying it by 10. 10 to the first power is 10, by the way. And we'll look at this. All right, does that go with everybody so far? All righty. Here's another one. Let's take a look at that. We have 143, which of course is not standard notation, or not scientific notation, times 10 to the negative 5. So we start out over here, and we take this number and deal with it first. 1.43, only one number to the left of the decimal, times 10 to the second, because we'd go 1, 2 to get it to its original form, times 10 to the negative 5. Just got to bring this guy down. So we have 1.43 times 10 to the 2 plus negative 5 power. 1.43 times 10 to the, okay, 2 plus negative 5 you subtract because it's negative, and you're going to end up with a negative 3. Okay? So when you go to write that in standard note, this is scientific now. It is the true scientific. You go to write it in standard form, you're going to go 1, 4, 3. Here's your decimal place. You have to take it 3 to the left. So 1, 2, 3. Put in your zeros. And here's your standard notation. Okay? And there's the work for that. One more down here at the bottom of the page. Okay? We have 1743 times 10 to the negative 2. Again, the first thing you want to do is deal with this number first. 1.743. Okay, I've done number to the left of the decimal. And to get back to this is 1, 2, 3. So times 10 to the third power. Bring this one down. Times 10 to the negative 2. 1.743 times 10 to the 3 plus negative 2 power. 1.743 times 10 to the 3 plus negative 2 power is 1. So your standard notation then is 17.43, because all you're going to do is take it one place to the right because it's 10 to the first power. And there you go. Hope this was helpful. Hey, you really got to be sure that you write down the examples and stuff so that you know what you're doing, because when it comes down to it and you're responsible for answering questions like this on the test, there's really no excuse not to be able to get it right if you've got your notes right. Okay, so have a great day, and we'll talk to you later.